Okay, so hello and welcome to this video tutorial for the Engineering Mechanics Statics textbook by R.C. Hibbeler. So we have this fundamental problem here from chapter 2 of the textbook that states two forces act on the hook, determine the magnitude of the resultant force. So this is a deadly simple problem. As we might typically do for problems like this, we can start by drawing a free body diagram. So we've got this 200 Newton force acting here. We've got this 500 Newton force acting here. Let's add in some geometry to this as well. So we can add in our x-axis here. We can add in these angles here. So this 30-degree angle and this 40-degree angle here. 40 degrees, 30 degrees. Okay, let's just add these magnitudes as well. We've got 200 newtons here, and you've got this 500 Newton force here. So to solve this problem, I would do what is typical for problems like this, which is resolve horizontally and vertically. I've described what I mean by this in previous videos. So let's resolve horizontally for a start. We can say that the sum of the forces in the x in this case are going to be 200 cos 30 plus 500 cos 70, taking 70 here to be the sum of this 30-degree angle and this 40-degree angle. Okay, and when I bung that in my calculator, I get 344.2. Here I've got, well, let's move on and resolve vertically. So I can say in the vertical we've got minus 200 sine 30, minus because it's acting down, which is conventionally taken as the negative direction, and minus 500 sine 70. And when I bung that in my calculator, I find that that is equal to minus 569.8. So this number here is describing the horizontal component of our resultant force, so it's acting 344 to the right. And this here is describing the vertical component of our resultant force, so it's acting 569 down. We can diagrammatize this then. We can say it's acting 344 this way and 569 this way. So 344.2, 569.8. So this is something we've done before. We can say then that the magnitude of our resultant force is effectively like a hypotenuse here. And we can just use Pythagoras theorem to solve for it. So we can say that it's equal to the square root of 344.2 squared plus 569.8 squared. And we bung that in our calculator, we find that that is equal to 665.7. Okay, which we can round to 666 newtons. And there's our answer. It's not asking for the direction. All it's saying is determine the magnitude of the resultant force. Okay, so if you have any questions or comments about that problem, feel free to leave them in the comment section down below. Otherwise, thank you very much for watching.